Okay, I've been asked to go over a pretty difficult probability problem. This is found in the Barron flashcards, probability 39. Now, you're looking at a basketball player who makes one out of the first two free throws. That's very important to know at the very beginning, so I'm going to take a note of that. Makes one out of two. From that point on, the probability that they make the next shot is equal to a proportion of shots that they make up to that point. So we're looking if he takes two more shots, what is the probability he ends up making a total of 2 free throws? Okay. So starting at the very beginning here, right? Made a shot. 1 shot out of 2. So we've made 1 shot out of 2. So we're on the third shot now. So it's telling me that it's all based on how many shots we made before this. So on the third shot, made 1 out of 2 chance that we'll make it. It'll go in. And I'm going to call that, instead of M, make it and miss, we're going to go with S for score, excuse me. So 1 in 2 chance that they score. 1 in 2 chance that they miss. Why? Because before that, they made 1 out of 2 shots. And if they make 1 out of 2 shots, the probability of them missing is going to be 1 out of 2. So now we get to the fourth shot. Now 3 shots have been taken at this point. And they told us the probability of making the next shot is equal to the amount of shots made before that. So now we're on the fourth shot. 3 shots have been taken. We're assuming that 2 shots have been gotten in. Over here we made 1 out of 2, and we just made the next one. So that means it's a 2 out of 3 chance that that fourth shot goes in. Likewise, that means you would have a 1 out of 3 chance of missing the next shot. Now we go down to here, right? This is based on missing that third shot. So what that means is you made 1 out of 2 of the first 2 shots, and you didn't make the third shot. So you've only made 1 out of 3 shots. So that means that's the probability of you making that fourth shot. Now, probability of you missing is going to be 2 out of 3, because that's the complement. So now we've represented the next 2 shots in this sequence. First 2, again, got 1 out of 2. So that means for the third shot, probability of making it is based on the previous 2. You made 1 out of 2, so probability of making it is 1 out of 2. And the complement is 1 out of 2, so probably you could either get it in or miss it. By the time that third shot rolls around, right? This assumes that we got 1 out of 2, we know that. This assumes we got the second one in. So that means you have made 2 out of 3 shots. That's the probability of you making that third shot. And likewise, if you made that first shot, if you made 1 out of 2, we know that. Then we get that second shot in. Then, let's see. Then, yep, probably missing is 1 out of 3, because, again, that's the complement here. This isn't an easy problem, so bear with me. Now we get to here. Again, we made the 1 out of 2 shots, so probability missing is 1 out of 2. Now, what that means, if we've made 1 out of 2, and then we missed this one, we've only made 1 out of 3 shots, which is the probability of us getting the next one in. And likewise, the complement is 2 out of 3. So then we have to figure out the probability that you make up a total of 3 free throws. 2 free throws, excuse me. So then I want to follow the branches that give me 2 S's, 2 scores. This gives me 3 scores. That's not going to help me, so I'm going to take that off the agenda. We got score, score, miss. Hey, that's making 2 shots. So 1 over 2 times 1 over 3 gives me 1 over 6. Next, let's look at the next set of possibilities. Whoops. There we go. Oh, I didn't want to do that either. All right. So next, we made a shot, we missed a shot, and then we got one in. So that's 2 shots right here. We're looking at score, miss, score. So that's 2 shots going in. 1/2 times 1/3 gives me 1 out of 6. And then for my last set of possibilities here, again, score, miss, and miss. So that's not going to count. So I got 1 out of 6 chance of scoring, scoring, missing, and then 1 out of 6 chance of scoring, missing, scoring. So if I add 1 out of 6 plus 1 out of 6, it gets me 2 out of 6, which simplifies to 1/3. And you will notice that is one of our options here, B. This is tricky because this is a lot of dependent events. It all depends on what happens previously, and that changes the probability of what could happen next. So it's a little bit of problem solving here, but I didn't want to go through it nonetheless. I went with the tree diagram. Some people might have gone with some different strategies here, but that's the method that helped me. And hopefully this helps you when you see this problem or a similar problem.